Good afternoon, everybody. I hope lots of people have managed to join by now. And we will kick off this last webinar session from a week full of great presentations that my colleagues have already done. We will conclude the week with a presentation regarding Kubernetes, self-managed to Azure. This is the second book in the trilogy, so stay tuned. That's a small hint for what's to come next. We will be discussing our journey from a self-managed Kubernetes cluster to Azure managed one. Let's dive right into it, and we will start with some presentation. Hello, my name is Daniel. I'm a Java developer. I've been working with Yonder for quite a few years now, almost a decade. And my main passion is to fix things because I learn more about how the internal workings of some particular item is by fixing it, not by just building it. So I'm not a big fan of IKEA. And this is the engineer in me talking. Let's have a small recap about where we left off in the last webinar. We wanted to build a centralized logging component that would gather logs from the service bus that we exposed from our monolith application. We wanted to use only relevant data. We wanted to make the application containerized. And of course, the celebration in the end. Who doesn't want to celebrate success, right? And because our application was being containerized, we wanted to use an orchestrator. We chose Kubernetes, and we ended up not on a final step, but on a pit stop around the campfire, reminiscing the whole adventure that we had so far, from idea to a product that was in production and customers were already using on a self-managed Kubernetes cluster. The main benefits of Kubernetes, we went over them last time. I will not go into further detail, but yeah, it's a pretty common knowledge right now. More and more people are using Kubernetes as an orchestrator because it's an open source container orchestration, and it's of course designed to do what we developers love to do: automate things. It automates deployment, scaling, and also management of containerized applications. It offers all these great benefits like scalability, high availability, uh, and load balancing. It is self-healing. That's one of the greatest things that I discovered about it, because it can restart, it can auto scale, it can kill containers when they're not functioning properly. It offers automated rollouts and rollback. It can, because it's a cloud-based architecture, it can offer an abstraction layer over the cloud provider. So you get the freedom of doing whatever you want without the fear of not being totally in control. Well, you're not totally in control, but you still are there on the reins, let's say. When done properly, it can also offer lower costs. You get the infrastructure, but not the cloud provider's specific resources. And this is one of the biggest pluses that it offers, because it's really portable. You can deploy a Kubernetes cluster and your application on any cloud provider. We will just talk about the structure of a Kubernetes cluster, just to a small reminder for you. It consists, of course, of several nodes. One or several of them will play the role of master, and they will store the state of the cluster. And it will also communicate with the API, through the API server and controller manager with the other worker nodes. The worker nodes are the ones that actually run your workloads, your deployments, your application. The masters are there for conducting everything, and they usually run just internal resources. Where we ended up last time was that we managed to build a small application with a backend server and front-end server. We deployed the application together with all the dependencies that we needed for it to function properly on a Kubernetes cluster. And the way it worked was that a system, in our case, the monolith application, would connect via an nginx that acts as a load balancer and a reverse proxy to the exposed Graylog input to send some logs. And Graylog will store them in Elasticsearch, which has the persistent volume attached that's running on a separate machine as an NFL server. And external applications can follow almost the same route to send logs to our system by connecting to the same nginx, but this time they will go to the backend server. We have an API exposed for that, and the backend server will send the logs to be stored in Elasticsearch. At the same time, we have APIs exposed for the user, which can connect again through the nginx to the front-end server, to the UI. The UI will get the authorization and authentication information required from the WSO2 identity server. And then it will communicate with the backend server to get the required data from Elasticsearch. The backend is built using it's a Java Spring Boot application. Content is a Vue.js application. Like I said, we use Graylog, which has an Elasticsearch attached to it, and a MongoDB. Keep in mind that these three resources are clusterized, so we can always scale up or down. So we have a Graylog cluster and Elasticsearch cluster and MongoDB cluster within the same Kubernetes cluster. WSO2 identity server, which has the MySQL database, which is connected to the persistent volume. And we use several other technologies like KubeSpray for provisioning the cluster, Helm for deploying the components of Helm chart. And also along the way, we discovered we needed some other particular little things like MetalLB, which is used to get physical IP that the ingress controller needs to assign to a certain ingress. And we use the ingress to expose our API. And we also needed a Docker registry, of course, or a private registry to store our images and download them when needed. Along the way, we discovered that things are not as shiny as they were first presented. In the official documentation, it seems really easy to deploy self-managed Kubernetes cluster. All you need is some VirtualBox machine. You need to do some configuration on them, like configuring IP tables, setting up the host file, disabling CLinux. I don't know what else. Turning off PWAP, of course. Installing the prerequisites like Docker or another container runtime, kubeadmin, then just joining the nodes together and everything worked. It was not quite that easy, and it was a good thing because we managed to learn some really valuable lessons. And the most important would be that we understood how each component works. And more than that, we understood how each component can and will fail at some point. And troubleshooting really helped us in the end. And we, of course, had success. We couldn't have it any other way. Phase one was complete. Our application was in production on a self-managed cluster. It was used by customers. Everything was running fine. But of course, we have some problems. So I can see the opening poll questions right now. Sorry about that. Okay. Answers are half and half, but more people are inclined to use it, or at least use it in the future. And I can see some people are working with Azure. That's nice. So we'll be on the pretty much on the same page here. Okay, going back to the problems that we had. Again, this is a recap from the last webinar. There were lots of bumps around along the way, due to mainly due to the fact that we had to do a lot of virtual machine maintenance. So whenever we needed to do security upgrades on the machines, there were some failures involved, and we wanted to avoid that. We also got some tips and tricks, and most important tip from our experience was that you should get a cloud services provider. If you want to streamline your application, if you want to get rid of maintenance, then you should get a cloud services provider. It's private or public, really doesn't matter, whatever suits your need. And because we practice what we preach, that we were already set on migrating to a managed Kubernetes cluster. It was just a matter of choosing platform. Azure is a public cloud computing platform. It's offering cloud-based computing services. We wanted to go for one of the big competitors, for one of the big providers. So differences between them are found online. Of course, Amazon is in the lead in some regards. Azure is a close second, also in the lead on some regards. Google Cloud is a strong third place contender. We were not decided which one to use, but the outcome would have been the same. As I said, Kubernetes is portable, so our architecture was not platform dependent. We could deploy on any cloud provider, and it was just a matter of making the decision. And after making that decision on choosing the platform, we got the approval and we were ready to start the migration. For starting the migration, what we did first was get a subscription, of course, and after getting the subscription, we gained access to the Azure portal. Azure portal is a browser interface where you can choose the resources you want to configure that you will need in your Kubernetes cluster or in your whole environment. We discovered that simple concepts translate to resources and services in the Azure environment. That was another pretty steep learning curve in the beginning. It set us back a few weeks, let's say, until we discovered the perfect solution. Next up, we needed to get an Azure registry. Well, it was already provided, but we needed to take a look at it and see how we can use it to store our images. Then the Azure Vault. Azure Vault is used for secret management. We can store and auto-renew certificates there, and then we can use them inside our cluster, within our application, wherever we want. We also got some Azure disks and Azure files as storage. Of course, we needed persistent volumes to be attached to them and to be created on them, sorry. And afterwards, we could already go on provisioning the cluster using the Azure DevOps. And we gained access to the AKS, which is the Azure Kubernetes service. We were already using some GitLab pipelines, so we were familiar with it, but they were just in place for building images after the code was committed. We were still deploying the images manually, a tied-out cluster using Helm, and we wanted to change that a bit and automate the process even more. We are all familiar with a basic representation of CI/CD pipeline. So as a developer, let's say when you want to work on a functionality, pull the code from your repository, in our case GitLab, you do the work, you commit and push the code, and then we had a pipeline in place that would package the application, do all the necessary tests, and it will result in a Docker image. Like I said, we used to store the images in the GitLab registry, and for this Azure migration, we wanted to store it directly in the Azure registry. So we managed to do that. I will show you in a moment how. And we wanted to set up a second pipeline that would take care of actually deploying the resources from the images created in the Azure registry in our Kubernetes cluster. We did that again using GitLab pipeline that uses Helm. And we had a look at the GitOps workflow, which is a newish service that GitLab provides, and it did not quite suit our needs. It doesn't offer templating tools support, well, not fully. They're still in the works with that. So it does not offer support for Helm, KPT, or Customize. And there was another caveat was that the agent and your project were needed to be in the same project structure. And if not, if your project is separate, then it needed to be public, and we didn't want to do that. Of course, we can remember the snake, the self-eating, self-consuming snake of CI/CD. Well, like as some brief examples, of course, this is not a production ready, but just to give you a small hint of how we did set up the pipeline. When you commit the code, we had this pipeline in place. That one of the stages of it was to package the application. And we would get from some variables the Azure registry login credential. And in the end, we would read the configuration from the Docker file. Docker would package the application in an image, and then it would push to the Azure registry. I said we used the GitLab Kubernetes agent, and to make the connection between GitLab pipeline and the actual Kubernetes cluster. This is running inside the Kubernetes cluster, and we set up another pipeline that connects to that agent. It will get the kube context from that agent, and afterwards we can run a Helm command. As we can see here, we apply a Helm file. The Helm file points to another Helm file in the path of the project, We can see it here, not fast but furious. Oh, nice name. This is another application that has its separate helm file and values YAML, and it will deploy it in the cluster. There is another way of doing that, a simpler way of running just kubectl commands. Like we see here, this is the GitLab PI YAML file. Again, it connects to that agent, gets the kube context, and then packages, deploys the YAML file that we need. We can deploy all sorts of resources like config maps, cron jobs, ingresses, and so on. And for now, we decided to stick to using the GitLab agent, but we do not want to exclude the possibility of using GitHub workflow because it seems really nice. The way it works is that the same agent listens in turn for changes in your project. So you point the agent to your particular project, and when you do a commit, it automatically deploys the image on the cluster without needing to start the actual pipeline, if you so decide. So it was time to do the actual migration. We had the pipelines, we needed to run them. Okay, we ran the pipelines, we pushed the images in the registry, and then we managed to deploy the images on the newly created Kubernetes cluster. There was still one little detail, which was regarding the data migration. Of course, we had our data stored locally on a virtual machine. So in order to do that, after checking out some possibilities, we decided to create a local snapshot for Elasticsearch and then upload the snapshot to the newly created Elasticsearch in Azure using a VPN tunnel that goes through the virtual private network and the private endpoints that we were provided. Now, reminiscing the issues that we had in the past with the whole headaches, especially with the maintenance, let's compare the two situations, the self-managed cluster and the Azure managed cluster. Of course, now it is provisioned and maintained, so there's no networking or kernel compatibilities, no cluster infrastructure related issue like we used to have. For example, whenever we needed to do a security update for one of the virtual machines, sometimes it requires a reboot. We needed to do the reboot in a certain order so we don't lose the state of the cluster. If you remember, the Kubernetes masters keep the state of the cluster. And if you reboot all your masters at the same time, you will lose your state. So you would have a fresh new cluster that's working, but nothing deployed on. Not ideal. And of course, we followed up with our tips and tricks. We saw that we managed to get a cloud services provider. Also, we did all the configuration that we needed and all the configuration that we didn't need, just to make sure. We had disaster recovery set in place with GitLab pipeline and Terraform. We have automated rollout and rollback. We defined auto scaling, of course. We're using provisioning tools, like I said, the DevOps pipelines, and logging, the most important. We did not forget about it. We have automated backups. We defined the resource consumption, and most of our headaches are already gone. Just some small issues remain. These were regarding the Azure resources, because not every cloud has a silver lining. There are a lot of them, and there are a lot of them which are available, but they're not included in your, they are included in your subscription, but you must know how to use them. Funny story was that a colleague of ours, started a service in Azure that was billed by the hour and forgot about it. And he got the bill in the end. Not ideal for him at least. Okay. The Azure Vault, we wanted to use the Azure Vault for TLS secret management, but we discovered it's not that easy. We made the assumption, I know, never make assumptions, but we made the assumption that it can handle TLS management. But in fact, it just offers secret management and certificate management and auto renewal, which is good. But we still had to create a workaround using a TLS secret provider and a TLS bootstrap pod that would get the certificate and the key from the Azure Vault and then deploy our TLS so it can be used by our ingresses. We also had some firewall and networking management to do. It was a lot of them. This also required at some point redoing everything because rebuilding everything because we decided that it's best to do it properly instead of just patching things up. And we wanted to use Azure Active Directory. That's still in the works because we had some issues with it. But yeah, we're going over them as soon as possible. We also have some tips and tricks for you. Again, not the tips and tricks that everybody would give you, but tips and tricks that we extrapolated from our experience. Try to use managed services, especially for databases. You do not want to do the database management yourself. For this, for example, we try to use Cosmos as an alternative for MongoDB because MongoDB Atlas cannot be included in your subscription. So we searched for an alternative. We did not manage to use it because we needed cap collections, and Cosmos DB is not fully prepared to handle MongoDB cap collection. We had a look at Elastic Cloud to use that. For now, it does not seem like a good option for us, but for you, maybe it would be best to try and use them. Always tag your resources. This is really, really handy at some point because you might lose track of all the resources that are being used, especially if there's more teams involved. You might find a resource that you don't know who uses it. If it's still in use, you don't know who's accountable for it, for starting it, and you can easily identify which of the resources you can get rid of in order to optimize the cost. Another tip, use Azure CLI. At least for me, that was easier than working with the web interface, especially for doing trivial things like deploying a new resource. So you can install Azure CLI and connect to your subscription and to a certain tenant via a terminal, PowerShell, or whatever you're using. Get an Azure certification if possible. It will give you a greater understanding of how every service works, and in the future it will help you not waste time with deciding which service you need in a certain point. Use the advisor. Azure provides an advisor that gives cost, security, performance, and a great number of other recommendations. Use Microsoft Defender for cloud. Again, this one gives you some recommendation regarding security. It always assesses your resources, and it can also assess your subscription and organization. We use this mostly for the insight that it provides regarding the images stored in the Azure registry. Logging, not I will not dwell on this again. Logging is really important, not for pinpointing when a certain thing happened or a problem happened, but pinpointing uh, the exact failure that caused it. So it will help you not encounter the same issue in the future. So you don't need to treat the symptom, you need to treat the cause. And also another tip is check the cost. Some resources, like I said, are included, but some are available and will generate extra costs. Some of the resources that are included are basic, and you might need another tier above that, and that will generate extra costs. So it's a good thing to check up on it. It's usually it's cheaper to use Azure, but yeah, experiences might differ. And speaking of dinero, let's take a look at the return of investment. The return of investment for us, it was not about the money necessarily, but it was mostly about the future-proofing our application. It provided us, the developers, with the possibility of focusing on actually developing functionality, solving customer issues, and not have to deal with maintenance. No more maintenance. Well, not in the sense that we were doing in the past. Of course, because it offers a faster development cycle and incident handling, we also have faster time to market. Right now we have optimized our costs, so IT costs are really spot on where they need to be. We are highly available as an application now. In the self-managed Kubernetes cluster, the application itself was highly available within the Kubernetes cluster, but the Kubernetes cluster itself was not highly available due to failures in the virtual machine that we had. And other applications in our organization have already followed suit and are close behind us in migrating to the Azure managed cluster. So we consider that one of the best return of investment. We are looking into migrating also the monolith application. This will pay off in the end big time. Now, take this with a grain of salt. Other solutions might better fit your needs. So this was just our personal experience with it. Like I already mentioned, future plans are to use the Azure Active Directory, make use of as much of the database services that we can, and follow up with our promise on migrating the monolith application, the old one. We also recommend the same documentation, the official one. Of course, there are other forums and other communities where you can get help, but get started, just read the official documentation. I also, of course, cannot cannot not recommend the Google comic from for Kubernetes from when it was donated by Google to be open source. And if you have any more questions regarding the first part of the presentation, that would be the small recap. I recommend the Yonder YouTube channel. You can find there the Kubernetes Book of Creation webinar, and that might clear things up for you. Now, let's take a Q&A, but before that, I would like to thank you all. Thank you all for participating in this webinar. Thank you all for participating in all the other webinars that have happened this week, and hope you have a great weekend. Sorry for looking away. Okay. Let's take a question. Yonut, hello Yonut, how are you doing? You've mentioned both no maintenance and using the Azure CLI. Are there any manual steps that you still need to perform as part of the dev release cycle aside from debugging and investigation? Well, keeping debugging and investigations aside, great question. You do not need to do any more maintenance. In a usual situation, you just do your work, you commit the code, you run the pipelines, all the tests are automated. Azure Defender kicks in, tells you, okay, the image is okay. And if you don't have any problems, you run the second pipeline, you deploy on the application, and then you can test it works. So no more manual steps are needed. Katalin, why did GitOps did not work for you? I believe I already answered that question. Like I said, it does not offer full support for templating tools like Helm, in our case, that we needed, also KPT and Customize, especially Customize. I've seen on forums that people are still having problems with that. And also the most important one was that we needed to make our project public, and kind of defeats the purpose of having a private GitLab and making your project public. Okay, should we wait for more questions? I can wait for 1 minute longer. Oh, my pulse is already 135. That's still in the green. Okay, if there's no more questions, thank you for attending again. I hope you had a great week together with us, and hope you have a marvelous weekend. Bye-bye.
You have one more question, Daniel.
Oh, sorry, didn't see it. I believe my internet is slow. Cost-wise, can we get some approximate number for the Azure managed solution? No, sorry, anonymous. I cannot discuss cost. We did some comparison between the virtual machines that we're paying for in our self-managed cluster, and what would mean to get a basic subscription from Azure, and it was much cheaper. That's all I can say. It was time cheaper. But it really depends on your application and how much resources you need. If it's a simple application, you might get away with the basic subscription and with the included tier, free tiers. But if it's a bigger application, you need to deploy more resources that you did not account for, and that would imply bigger costs. Also, availability time zones, that's another availability zone, sorry. That's another issue to keep in mind. If you want one or more to make it highly available and foolproof, then that will increase the cost again. But you can get an approximation from Azure itself if you're interested.
Now you've covered them all.
Okay, now can I say have a great weekend?
Of course.
Of course. Again, have a great weekend. Thank you for following us so far, and hope to see you again next year or maybe sooner. Who knows?